Hi everyone. In this video, I will talk about the sigma notation. Now, here is the definition of sigma notation. It says the sum of n terms a sub 1, a sub 2, a sub 3, and all the way to a sub m is written as sigma of a sub I from 1 to n. And this notation is equal to is equivalent to the sum of these n terms, where in this formula I is the index of summation, and ai is the ith term of the sum, and the upper and lower bound of the summation are n and 1. Okay. So this definition shows us when we have a sum of several terms. Say here we have a sum of n terms, and then we can write. We can use this notation. We can use this symbol to represent this sum. So in this notation, the I is the index. Now you can use X, you can use J, you can use K. It doesn't have to be I. So the I is just a variable. Okay. Now this variable equals 1. That means the first term it starts at 1. Now if this equals 2, that means the first term starts at 2. And the upper bound, this tells us it tells us what is the last term. Say if this is 10, if n equals 10, then that means the last term is the 10th term. Like if we have this sigma notation where I equals 1 from 1 to 9 ai. So in this sum, there are 9 terms. The first term is a1 plus a2 plus a3, and the last term is a9. How do I know it's a9? Because it tells me the n equals 9. Now, if the first term is not 1, if we have I equals 3 to 9, then I know in this case the first term is not a1, the first term is a3, and the next one is a4, a5, a6, 7, a8, and a9. Okay, so this is the information, the index and the start value and the end value tell us. Okay, and next, the AI. The AI is a formula we use for determining each term. What does this mean is we can think the AI as a function. Okay, as a function. So in this function, the input value is I. In other words, we can see AI as a function of I. So the input value is I. So when we give a different value of I, the result will be different. For example, let's say if we are given that AI, the function AI has the equation 2i plus 1. Okay. So therefore, when I equals 1, the first term a1 gonna be equal to what? We can use this formula to determine that. When I equals 1, a1 gonna be 2 times 1 plus 1. So it will be 3. And when I equals 2, the next term, A2, gonna be A of 2. So that will be 2 times 2 plus 1. So that will be 5. So this process is very similar to the process of evaluating a function. Now here we just we're given a bunch of input values, and we are asked to evaluate the function at each value, and then we add up the function value together. Okay. Now after we see this, let's look at some examples. All right, so here we have this sigma notation. I is from 4 to 7, and for I square. So this I square is the formula for AI. So here the function we're using is the definition of this function, or the equation of this function, is AI equals I square. Okay. Now remember, since I starts at 4, so the first input value we're gonna use is 4 and not 1. Okay. So the first term is A of 4, and then plus A of 5, and plus A of 6, and plus A of 7. All right, we stop here because 7 is the last input value. Okay, so then let's see, what does A of 4 equal? So A of 4 equals 4 square. So this is 4 square plus A of 5 is 5 square, and 6 square, and 7 square. Okay, and then we just figure out what is the result is. Okay, so the result is 126. So this sigma notation equals 126. Okay. Okay, let's see another one. Now, in this sigma notation, the index value starts at 0 and ends at 5, and the formula of AI is I plus 1. So here we have in this sigma notation, in this sum, we have 6 terms. The first term is A sub 0, A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. Right, so there are 6 terms. Okay, so the first term, the value, so for the first term, the input value is 0. And since the equation is the equation of the function is I plus 1, when I equals 0, the function value is 1. And the second term, the input is 1, so the function value is 1 plus 1 is 2. And for the third term, the input is 2, 2 plus 1 is 3, so 4, and 5, and 6. Okay, so the result is 7, 21. Okay. Okay, now we know how to evaluate the sigma notation if we're given everything. Now next, I wanna show you some formulas. Using these formulas, we can find the result of some sigma notations very quickly. The first formula is if we have a sigma notation where the formula of AI is a 1. So this means here the AI is a constant equals 1. Like here, the sigma of 1 where I from 1 to n. So this means the first term is 1, the second term still be 1, the third term still be 1. So since we have n of 1, we have n of 1 adding up together, so the result gonna be equal to n. If we use the function to think about this, this is like in this sigma notation, our function is a constant function. The function value is always 1, no matter what our input is. Okay. So like if we have the sigma I equals 1 to 20 of 1, so the result gonna be 20. Now if we have a sigma of I from 2 to 20, now this time the result is not 20, the result is 20 minus 1. Why? Because since I is not starting at 1, so we have to subtract 1 from 20. So in this case, we only have a 19 of 1. The next formula is okay, if we have sigma of I, where I from 1 to n, like 1 plus 2 plus 3 plus all the way to n. Now the sum of this equals this, equals n plus 1 times n over 2. So the result depends on the n. Now in this sigma notation, our AI, the formula of AI is I. So the function is like a linear function, like f of x equals x. The function value equals the input value, right? So when input is 1, the function value is 1. So that's why the first term is 1. The second term, when I equals 2, when the input is 2, the function value is 2. Okay. This formula shows us when we add 1 all the way to n, the result is given by this formula. So, for example, when I have this sigma notation I from 1 to 6, now using this formula, we can see the result is 6 plus 1 times 6 over 2, which equals 6 over 2 is 3. 3 times 6 plus 7 is 6 plus 1 is 7. 7 times 3 is 21. So that's why here the answer is 21. Okay. Let me use a few minutes to show you how we derive this formula. Okay, so let's see if we have now if we add 1 by 2 by 3 and all the way to k. Now if first we assume if k is an even number. So k is an even number. Let me write a few more terms. Okay. Okay. So if I add 1 by k, what do I get? I will get 1 plus k, right? And then if I add 2 by k minus 1, I will get what? I will still get 1 plus k, right? And if I add 3 by k minus 2, I will still get 1 plus k, right? So how many of 1 plus k do I have? Remember we said since k is an even number, so there will be in total there will be k over 2 of 1 plus k. Therefore, the sum of this we can use a multiplication, which is we multiply 1 plus k by k over 2. That will give us the sum of this. Like, suppose I add 1 all the way to 6. You see, first I add 1 by 6, I get 7. Then I add 2 by 4. Sorry, I missed 5. Okay, I'm adding 1 by 2 by 3 all the way to 6. Okay. Now I first add 1 by 6. Okay. I get 7, and then I add 2 by 5. I got 7, and 3 by 4. I got another 7. So this is 3 times 7 because I have 3 of 7s. Okay. All right. And how the 3 comes out? The 3 is the total number of terms, 6, right? And divided by 2, because when we divide it by 2, because we consider there are 3 pairs, right? And the 7 is the sum of the first number and the last number. Okay. All right. Now, what if k is an odd number? Now, if k is an odd number, we cannot use this technique directly. Because why? Because there is a one number in the middle that we cannot pair with any numbers. Like here, we can pair 1 with 7, 2 with 6, 3 with 5, but 4 we cannot find a number to pair with. So in this case, we can use a trick, which is we add one more number after k. We add one more number, k plus 1. Now, since k is an odd number, therefore k plus 1 will be an even number. And then we can repeat using the previous technique. We add 1 by k plus 1. So we can get a k plus 2, and we add 2 by k, we get another k plus 2. So how many of k plus 2 do we have? Since right now we have in total k plus 1 numbers, so there will be how many pairs? K plus 1 over 2 of these numbers. And then we multiply k plus 1 over 2 by k plus 2. This will give us the sum of this from 1 to k plus 1. But remember, we want to find the sum from 1 to k, so we subtract this result. We subtract k plus 1 from this result, and then we do like a math technique. We can factor out k plus 1. So to get k plus 2 over 2 minus 1. And we simplify the inside by writing 1 into 2 over 2. So this will be k plus 1 multiplied by k over 2. So therefore, no matter if k is an odd number or an even number, the result of this sum is always equal to, is always represented by this formula. Okay. Now for the next one, if the formula of AI is I square, like a 1 plus 2 square plus, so 1 square plus 2 square plus 3 square plus 4 square all the way to n square, the sum of this is given by this formula. Okay. N times n plus 1 times 2n plus 1 over 6. And if it's a sum of the cubes, the result is given by this formula, a n squared times n plus 1 square over 4. Now remember, when we use these formulas, we want to check if the index starts at 1. If it's not starts at 1, after we figure out this result using this formula, we have to minus the terms, the value of terms we missed. For example, if here we have the summation of I from I start at 3 to 6 I square. So this, since this equals 3 square plus 4 square plus 5 square plus 6 square. So when we use this formula, we have to subtract the 1 square and the 2 square from this result, because we don't have that two terms. So this will be equal to 6 times 6 plus 1, 7 times 2 times 6, so 12 plus 1, 13 over 6, and then minus 1 square and minus 2 square. So that will give us the right answer. Okay. Okay, now let's use these formulas to solve for these two problems. So here we have a sigma of I, where I starts at 1 and ends at 10. So the formula we're using is this one. Now since I starts at 1, so we can just copy this formula. Now n equals 10, so we substitute 10 for n into the formula, which gave us 10 plus 1 times 10 over 2. So answer is 55. For this one, the n equals 100. So we have 100 times 100 plus 1 times 200 plus 1 over 6. There are two properties of sigma notation. The first property says if each term ai has a constant, then if this constant is the same, we can we can we can fact out this constant. So we can find the summation of ai, and then we multiply that by this constant. For example, if we are given the sigma of 3i squared, since each term I squared has a constant 3, so we can fact out this 3, and we first find out what is the summation of I squared, and then multiply that by 3. Now this is in this problem actually we use the distributive property, right? So because this summation, when we write this out, this is like 3 times I square, 3 times 1 square plus 3 times 2 square plus 3 times 3 square plus 3 times 4 square, right? So since every term has 3, so we can fact out this 3 and have 3 times 1 square plus 2 square plus 3 square plus 4 square. And this summation, the summation in the parentheses, we can replace by this sigma notation, by this sigma notation. And the second property says if we have a summation of a term a1 plus or minus another term b1, then we can write this as the summation of a1, so ai plus minus the summation of bi. So for example, let me erase this. Like the summation of I plus I squared, where I from 1 to 5. We can rewrite this into the summation of I plus the summation of I squared. Now the advantage of doing this is next we can use the formulas we learned here to figure out what is the result of each summation, and then we add them together, we can find the answer to this. Okay. Now next, let me do some problems from the homework. So let's start with this one. Use sigma notation to write the sum. So here we're given this sum, and we want to write this into sigma notation. So here require us to figure out a couple of things. First, we want to determine what is the end value. What is the end value of the input, and what is the formula for the AI? Okay. Let me do it here. So the first term is 1 over 4 times 1. The second term is 1 over 4 times 2. And 1 over 4 times 3, all the way to 1 over 4 times 15. So remember we said we can see AI as a function of I, right? So when you look at each term, we can see only the value in the parentheses are changing, right? And other numbers are constant. Therefore, we can determine this function is 1 over 4i. So the input is I. The input is these numbers 1, 2, 3, and 15. And so here we can go ahead to put 4 times I. Okay. And since the last term, for the last term, the input is 15. So we know there are 15 terms. Okay. All right. Now we can use this the same method to figure out 7, 8, and 6. Okay. All right. Let me do some other problems. Use the property of summation and the summation formula to evaluate the sum. Let's see this one. We have a sigma of 8i minus 3. And I is from 1 to 14. So to do this problem, we first gonna use this property. So according to this property, we can split this into two sigma notations. One is sigma of 8i, and the second one is a sigma of 3. Remember, the sigma of 3 means we have a 3 added by 3 added by 3 for 14 times, right? We can use the first property, because here we have a constant 8. We factor out that. Now our sigma becomes the sigma of I. And for the second sigma notation, we can also factor out 3 to write this into the sigma of 1. Okay, now we are finished using the properties. Next, we're gonna need these formulas to figure out what is the result of each term. To find out what is sigma of I, we use the second formula. Equals n plus 1 times n over 2. Here the n is 14, so this equals 14 plus 1 times 14 over 2 times 8. Okay, and minus the sigma of 1 equals n, so this equals 3 times 14. Okay. Now 14 divided by 2 is 7. So this is 8 times 14 plus 1, 15 times 7 minus 3 times 14. 8 times 15 times 7. So it's 840 minus 3 times 14, that is 42 minus 42, 798. That's our answer. For number 11, well, first we're gonna use we're gonna factor I minus 1 square. We're gonna multiply out what is I minus 1 square. Because I minus 1 square, when we write this into a polynomial, that is I square minus 2I plus 1. So this summation is equivalent to the summation of I square minus 2I plus 1, which equals, then using the property of the sigma notation, we can have the summation of I square minus the summation of 2I and plus the summation of 1. And for the second summation, we use the first property. If we use the first property, the second summation, we can factor out 2. Then to evaluate each summation, we use these formulas. So the summation of I square equals n times n plus 1 times 2n plus 1 over 6. So that is so here n is 10, so it's 10 times 10 plus 1 times 2 times 10 plus 1 over 6, and minus 2 times the summation of I. We use this formula, so that's 10 plus 1 times 10 over 2. And the summation of 1, that equals 10. So this is 10 times 11 times 21 over 6 minus 2 and 2 are cancelled, minus 11 times 10 plus 10. 6 and 21 they have a common factor 3, and 2 and 10 has a common factor 5. 5 times 11 is 55 times 7 minus 110 plus 10. Okay, so the result is 285. Okay, so this is how to evaluate sigma notation.